So in this question we've got a parametric curve defined as x equals 2 plus 3t over 10 minus 2 cosine t, and we're given y equals cosine squared t, and what we're interested in is t is from 0 to pi over 2, and this is a graph here with a shaded region that we're trying to calculate. So what we want to do is calculate the area of the shaded region. So what that's going to do is we're going to need to find an integral. So what our basic building blocks are, so we'll have a point A and a point B, and we'll have y dx dt with respect to t. So we need our points A and our points B, and we need our dx dt. Well, here's our x, so let's find the derivative of that first. So the derivative with respect to t of 2 plus 3t over 10 minus 2 cosine t. So derivative of 2 comes to 0, 3t over 10 just gives us 3 over 10, so we've got 3 over 10, and the derivative of minus 2 cosine t, well, the derivative of cosine is negative sine, so if we have negative times a negative, that gives us a positive, so it gives us 2 sine t, so plus 2 sine t. So that's our dx dt. Now our a and our b, well, that, as we're going to integrate with respect to t, our a will be 0, so a equals 0, and our b equals pi over 2. So with that, let's put our information in because we've got y is cosine squared t. So let's deal with that. So a is 0, we've got pi over 2 for the upper bound, y is cosine squared t, and then our dx dt is 3 over 10 plus 2 sine t. Now we must put this in a bracket, so I've got 3 over 10 plus 2 sine t, and then our dt. Okay, so now I'm going to expand out the brackets, so that's going to simplify our integrand furthermore. So 0 to pi over 2, 3 over 10 cosine squared t. Now what I'm going to do here is I'm going to split my integral. So I'm going to have this one times this one. The parameters will stay the same for both parts. So this is what's going to happen. I'll bring the 3 over 10 out to the front, and I'll have cosine squared t dt. Then I can add, then I'll have a new integral from 0 to pi over 2. Pi over 2, so that'll be that. Then 2 sine t times cosine squared t. I'll bring the 2 out to the front, so 2 cosine squared t and then sine t dt. So now I've got two integrals going on. This one here, to get this integral, I'm going to need a trig identity, and for this one I'm going to need use substitution. So it's going to involve two different methods to solve an integral on the same question. So this one, I'm going to change this to a trig identity. So we're going to need 3 over 10, 0 to pi over 2, so that's going to stay the same. Now cosine squared, I can rewrite that as 1/2 plus cosine 2t over 2, and then I put my dt in there. That is the same value as cosine squared t. So that's that. This one, I'm going to need a u substitution. So let's deal with this one. Now, as I've got different integrals, I can leave this one in terms of t and this one in terms of u. That's fine, that's fully legit. So as I've got cosine squared, I want to let my u equal cosine t. So let's deal with that. So if u equals cosine t, then I now need my du with respect to t. So derivative of cosine, so du equals negative sine t dt. So then let's put that in, but let's change our parameters while we're at it. So if t equals 0, so then what I want for is for this, so t equals 0, so u would equal cosine 0, which would be 1. And then at t equals pi over 2, u equals cosine pi over 2, which is then 0. So that would take care of that. So let's put all those building blocks into there. So I've got plus 2, or in terms of u now, so at 0 I've got 1, and at pi over 2 I've got 0. So that's at 1, that's at 0. Cosine squared is u squared, so that's u squared. Sine t, that will now be taken up by this negative sine t, so I'll just put that in there so you can see. So sine t dt, but dt is now du over negative sine t. So that takes care of that. So that would, the two signs would disappear, and then I'll have this minus, which I can now bring out to the front. So let's calculate what this one is. So the integral of this, I'll have 3 over 10. So 1/2 with respect to t just gives me t over 2. And then cosine 2t. Now the integral of cosine will be sine, and then by the reverse chain rule, I'll have to divide by the new by 2. So then I'll have sine 2t over 4. So sine 2t over 4. And that's from 0 to pi over 2. Okay, so that's integrated. We just need to evaluate what that is. So now let's have a look at this. So now let's carry on this integral over here, and then we'll bring the two values together. So now bringing this over here, let's keep this all separate. I'll have minus 2, integral from 0 to 1, sorry, 1 to 0, sorry, 1 to 0, and then I'll have u squared du. Okay, now I can change these parameters round, so I can have that now with this 1 as the lower parameter. I can see it's larger than the 0, but with a minus here, I can introduce the minus, but then flip the parameters. So then I'll lose that minus. So 2 from 0 to 1, u squared du. Okay, right, we can integrate this. This is not a problem. So now I've got 2 times u cubed over 3, and that's from 0 to 1. Okay, now let's put the two integrals together and let's calculate what they are. So this one, so I'll have 3 over 10, and then let's calculate what we got here. T over 2 at pi over 2, that's going to give me pi over 4. And then sine of 2t, the pi over 2, that's going to give me sine of pi. Sine of pi is 0, so the rest of that disappears. So now I need to calculate what happens at 0. So subtracting what happens at 0, t over 2, that simply becomes 0, and sine of 0 is also 0. So the rest of this also becomes 0. Okay, now let's take care of this. So I've got 2 times u cubed over 3 from 1 to 0. Well, when u is 0, that disappears. So I'm simply going to have 2 times 1 over 3. So that equals 2/3. So then my final result will be 3 over 10 times pi over 4. So then our answer will be 3 pi over 40. And then 2/3 is left, so add that on. So add on 2/3. And that will be the answer to the area of the shaded curve. So let's write that over here. So I've got 3 pi over 40 plus 2/3. And then we are done.